class on software engineering, fourth semester paper, Unit 2. Okay. Software engineering, fourth semester paper, Unit 2. Okay. Okay, get me a presence. Hello. Okay, get me a presence. Hello. Hello. Are you guys there or you need some time to comment? Okay, I can see victory. Okay, get me a presence. Hello. 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 Okay. I think I'll start. Okay. Okay, then I'll start the class. Okay. So today's class, okay, so here I go with the class now. The paper is SE. I'm doing this second part. Okay. Unit 2, part 1. So I'm starting Unit 2 today. So we all see that there is an invention at some point of time. The first invention was, suppose there was a wheel being invented. Okay, we all invented the wheel, is it? Then after the wheel was invented, then people use the wheel for making the bullock cart, is it? My diagram is very good. Then the bullock cart was pulled by some animals here. Okay, then after this bullock carts which were pulled by animals, then we finally see in the modern day what we call as, we got something called as cars today. Fine. So from wheel to carts, and from bullock carts we came to car. Now this is an process of what we call as an evolution, is it? This is an evolution. Okay, excuse me for the handwriting. Now this is a process of evolution. Now this was just a practice. From practice it become a cart, and from cart craft it becomes an engineering. Okay, now likewise you can see this one. Initially people were making they got the art of making wheels. So from the wheels they went to the craft. That from the art it became a craft. Now from the craft people came to engineering. Okay, now what happens in art is people were using esoteric use of past experience. They were only using some experience, past experience, to build some device, not device actually, some some products. Then when this unorganized use of past experience happens, then people come with some kind of craft. Then they started crafting with that experience. Then further, semantic use of past experience and information with scientific basis will give us something called as an engineering. Okay, now we see that software engineering or software development also has some kind of art. Then it go to a part, then it comes to a thing called as an engineering. That means software engineering also has an, or engineering also has an evolution with time. So this is about evolution of technology with time. Fine. Okay, now I'll just read out through this one. Software engineering principles have evolved over last 60 years with contributions from various researchers and professionals. Over the years it has emerged from pure art craft and finally become an engineering discipline. So this was also a craft and finally it become an engineering discipline. Okay, I'll just read out this one. Now initially the evolution of software styles over the last 60 years. Okay, so the passage in which we are passing through this software engineering is more than 60 years now, because this book was written 10 years back maybe. So now it is 70 years. So we can easily notice that it has evolved from an esoteric art to a craft and finally to a engineering, the same thing. Now when we see this thing, I mean this diagram, it has some kind of crisis is there. Okay, when we see the diagram, now when you see this diagram, we see that there was some unorganized use of past experience is there when they were crafting. Then they were semantically using this one. Now when they were go from one phase to another, whenever there is, whenever they develop any product, there is always something called as crisis. Now why crisis happens? Can anyone say? When we develop any product, there is a problem, that crisis will always happen. Now in management or in engineering, in softwares, anywhere, whenever we develop any product, I mean products, and we were doing any kind of technology work, the crisis is always happening. Can anyone say, like, when we develop anything, why does the crisis happens? That is the main, that is one of the questions here. So if you can just think yourself and give me an answer, then you know the first question of this topic. So can anyone tell me why is this crisis there? Just get me an answer, anyone. This question is there. Why is this crisis there? See, whenever we design anything, we bring anything in market, we produce anything, there is always a crisis. Can anyone take crisis? Are you facing any problem with the video? Is the video visible to you guys? Having any issue with videos or anything? Can you tell me why the crisis is there in any product? Because that makes the basic formulation of our today's class. Okay, now I'll say this. The crisis happens whenever we produce anything new as we don't have enough experience, we do not follow the exact theoretical principles, that is one problem. We cannot deliver the product in time, that is one problem. We cannot develop the product as per the standard, that is another problem. The same practices we have been using for last 2 or 3 years, that is the problem. Okay, so these are some of the crises the software also faces. Okay, so okay, now causes and solutions for software crisis. Now software engineering appears to be among the few options available to tackle the software crisis. So one of the issue is we must know software engineering practices so that it can handle software crisis. Now let us explain this one by presenting software crisis in simple word. Okay, the expenses that an organization all around the world are incurring on software purchases compared to those of hardware purchases has been showing a worrying trend over the last few years. Now in last few years you must have noticed one thing, that the price of software is going higher day by day, and software and hardware price is coming day by day. You can see this diagram here, hardware versus software cost. In 1960s, for a person to buy a computer, say in Indian currency, it was not possible because 1960s there was no computer. Up to in 1990 also, when our college bought the first computer, somewhere in 1990s maybe, it was around 1 lakh. One computer was costing 1 lakh minimum, that too a very old black and white monitor computer. But today when you come, the hardware cost is very less. We can get a computer for 20,000 also now, is it? But when it comes to software, this is the hardware price coming down like this. But when it comes to software, the growth of software and software price is increasing day by day. Software is becoming more costly. So this is one of the crises happening in the software industry. Okay, now organizations are spending more of the time and more of like more of their budgets on not only on software products turning out to be more expensive than hardware, but also presents lots of other problems to the customer, such as software products are difficult to alter. See, once you buy a software, it's very difficult to make changes. Suppose if you are buy Windows 10, you cannot make changes in Windows 10 coding. It is very difficult to debug also, then enhance. If you want any new feature also, it's very difficult. If you want to enhance it, buying a software, you'll have to pay again money. Now others fail to meet the requirements. Sometimes these softwares are not reliable, there is a frequent crash or hang, and are often not delivered in time. So these are the problems we often see with softwares. Now, second problem is due to ineffective development of the product categorized by the efficient resources and usage and time and cost overruns. Other factors are large problem sizes, lack of adequate training in software engineering, increasing skill shortage and low productivity in means we don't have skilled peoples, we don't have efficient resources, and the problem size is very big, the demand is very high, and plus as per the demand the skill production is very less. So if you want to become a good software engineer, the demand is very high because there is still a lack of good engineers. So that's a very good scope for you, and there is a big demand of software global. Software engineers are the one of the most highly paid and highly in demand throughout the globe. Now, this crisis is a term used by computer science for the difficulty of writing useful and efficient computer programs which is required in time. Now, crisis means we cannot produce the thing in the right manner in right quality in time. That is the crisis. Now, software crisis was due to using the same workforce, same method, same tools, even though rapidly increasing IT industry was growing, but the idea was same. Now, with increasing complexity of the software, many software problems arise because existing methods were insufficient. So this in diagram I can show you. The crisis is happening because there is a huge demand, there is a complexity increasing in challenges. Okay, now the people who are working at same workforce, they are using the same method, same tools. Now we have to change that, is it? Now in fact it has changed. When this book was written, there was a lot of problems. The IT industry wasn't able to keep with the new tools and new methods. So you in exam you can write this one. We have crisis because the demand is high, supply is low. Workforce is same, we are using the same method. There is increasing challenges, complexity is going high. So this diagram clears what is a software crisis now. Now other type of crisis you see is problem of compatibility. It runs here, there it does not run. Problem of portability. We don't have proper documentation. Softwares are pirated. Problem in coordination of people. Problem of maintenance. This is a programmer point of view. A programmer says that whenever I write any software, I have this type of problem. Now user also gets a problem in software. He says that the product of software is very high. It's going day by day higher. When we want any document specification, it is not there. Like manual, we need the software manual every now and then we use. A problem in different version. Today you say there is one version 2.0, there is again 2.5 coming. So how many of you have been using Windows? We must have used Windows 7, then you're coming to Windows 8, then we come Windows 10, again new version will come, Windows 12. So different versions are coming, and plus there are errors and bugs. So these are all the issues here. Now, what is the remedy? It is believed that a satisfactory solution can come if we follow the software engineering discipline advancement in this one. We have to follow the best practices among the developers coupled with this. So it says that we have to follow the best practices of software engineering disciplines. Okay. So here I have given you, this is a question, it comes very often. What are the causes of software crisis? What are the solutions of this crisis? So it comes in exam sometimes. So just to explain you these two questions, so it comes up around 4 or 5 marks. Okay, I have gone so deep. I have gone from right from art and craft, but you must know that evolution of software engineering as a discipline. Okay, so there is a question and answer is yeah, fine. Now two questions are important here. Uh, you need this evolution of technology with time. Explain the evolution of software engineering over time. Explain. Next is what is the crisis in today's software industry. This is the answer. Next, oh sorry, not this one, this is the answer. Now what is the solution to this crisis? Fine. Okay, if any questions here, I just pause. In case if you have any questions now. Any questions? Okay. Okay, I'll go ahead. Okay, fine. So I'm going ahead now. Okay, I'll go to the next topic now. So this is important from this point of view. Till here, whatever we have done. Okay, what are the causes of software crisis and what are the solution of software crisis? These two are important. So you read this and the evolution of software engineering. Okay. Now these two terms are very much important. Okay, process and software process. Now what is a process? A process is a series of states or a series of activities, constrained resources that produces an output of some kind, or it is a kind, or I mean, it is a state that takes some input and produces an output. So basically, we have a process to cook tea. Also, is it? You take tea, so that then you burn in the put it in the warm water or hot water. So that is a process. So process is we have certain kind of resources, some rules. We have an input and we produce an output. Okay, that is the process. That means the way. What is the process of doing filling this form? So that is there are some kind of moves we have to do. Now, what is a software process? A software process is related set of activities and sub process that are involved in developing and involving a software system. So this is also a related set of activities and sub process that are involved in developing a software. So what is the process of making tea? Means there are set of activities in making tea. So what is the process of making a software process? Software process means those steps which we follow in making a software are known as software process. Okay. So this is just a simple term I have introduced you. Now the previous one discussed the evolution of engineering. Okay. What is software crisis? We just follow this questions. Explain reasons for crisis. What is the remedy? Remedy means solution. Okay. I have already given you this answer. This is the answer for this question. There's a slight mismatch in the slide. Okay. Now I'll come to the topic what is called as a software lifecycle method. Now this software lifecycle method is also called a process model. Okay, is a descriptive and a diagrammatic representation of a software life cycle. Okay, a life cycle model represents all the activities taken to make the software product transit through its cycle phase. It captures the order in which activities are undertaken. In other words, a life cycle model maps the different activities performed to develop a software. Okay. Now, say if you are having a picnic. Okay. Now, when you arrange a picnic, the first thing is you'll have a process of something like you are collecting money. So I'll just write here short form, collecting money. Then after you collecting money, you decide which will be the venue you will go. That means you select the venue. Then after the venue, you decide for marketing. Then somebody will go for marketing, somebody will go arrange for transport. Okay. Now you see that this is your activity. That means this is your process of going to a picnic. That means in this case, each of these activities are ordered. That means from collecting money, the next phase is you decide to go to the venue, then you do the marketing, then you, and finally one fine day you went to the venue. That means it shows a set of activities, is it? So when we have a software model, it also has a set of activities and it is shown very much diagrammatically. Don't worry, in this slide it will be clear to you in the next slide. So what is a software model? It says that it's a model which gives us a diagrammatic representation of a software lifecycle. Okay. And each phases shows the activities, and each of these activities are well connected in a proper and a timely manner. Okay. We have different type of models. We'll discuss only one today. Okay. Now, why do we need a model? So same question comes. Why do we need to plan to go a picnic? Why don't you collect money before doing the marketing? So each of them, they have their own phases. Is it? If there is any error while going to picnic, or you had a budget, then again you will look at the document and you'll say that no, we have to increase the budget. Or if there is a surplus budget, you decided something else. So we need this model also so that the engineers can plan basically. Okay. So I'll just read this one. The development team must identify suitable cycle models. There are many models. They have to select one of those models. And without using a particular lifecycle model, the software product would not be semantic and in a disciplined manner. So we need a model also to create a discipline. So when a software product is being developed by a team, there must be a clear understanding among the team members about what to do and when to do. Otherwise, it will lead to chaos in future plan. So we need a model to work. So when you're planning for a picnic also, you'll have a plan, you have a set of activities, you have to do certain things, that when to do, what to do, and how to do. Okay. So these are all been given in a software lifecycle model. So each of this lifecycle model has an entry phase and an exit phase. Okay. And without this, the entry phase and exit criteria phase cannot be recognized. So with, if we don't have, we cannot say where it is starting, when it is ending. Now one of the most common model we use is what we call is the classical waterfall model. Okay. There are other types of model also. Will do iterative model, waterfall, iterative waterfall. Then we have prototyping model, evolutionary, spiral. Okay. Now we'll just see one diagram. It will become very clear to you when you see this model. Okay. I'll just show you this diagram. You see this. This is a classical waterfall model diagram. This one. This is called a classical waterfall model. So this model describes each of the activities from one phase to another. First we go for this phase, then it goes to next phase, then it goes design. Okay. So they decide that we'll follow this model of classical waterfall model and we'll go from one phase to another. So at any point of time, they can ask the engineer, you are in which phase? So the engineer may say that I am currently in a coding phase. So I'm completed till here. I have to complete the next two phases here. Okay. Okay. I'll just give a pause here if you have any questions. If you have any questions, you can just type in the question there. Any questions anywhere? So basically you will need this one. I mean, this causes of software crisis. And this one you need this causes and the solution. Then you have to know this question: evolution of software engineering. What is crisis? What is its remedy? These questions. Then we have come to what is called as a model. So this I'll leave it up to you now. These different phases of classical model. Okay, this is feasibility study, requirement analysis, design. I have already done coding, unit testing. Is there in the notes? You just read this. I have told you about feasibility study and all. Okay, so it's there in the notes. You can just go through. Okay, so I'll stop here. If you have any questions. Basically, you need this one. So this I'll model. Okay, this is so. Software engineering. Okay, then Okay, so that's it for today. So I'll just stop here. If you have any kind of questions here, yeah, I'll do the okay. I'll upload the slide also. Don't worry. I'll upload this slide